Okay, so I'm gonna talk about frame independent motion and frame dependent motion and why this is important. So, frame independent motion is when the movement of the player or whatever, an object in your game, is not based on the frames. Such as movement is usually can be based on delta time, for example. We'll talk about later what delta time is. And frame rate dependent motion is when the movement it is indeed based on the frames. So let's say your game runs on 60 FPS, 60 frame per second. That means every object is getting updated 60 times per second. However, though, if the frame rate increases, let's say the frame rate goes 250, or decreases, let's say it drops to 20 or 30, then this movement is affected. If the frame rate is faster, the movement is faster. If the frame rate is slower, the movement is slower. So in a frame rate dependent motion, your object movement and speed is affected by it, and you don't want to have that. In old video games like Game Boy, Nintendo, Atari and stuff like that, they used to do this. They were using this method, and the reason they're using this method is because the hardware was always the same. It was the same game console, and the resolution was always the same, and pretty much the refresh rate on the monitor was, I would say so, pretty much the same. So now when you port that game to a computer run through an emulator, the emulator has to have certain hacks and optimizations to make this run smoothly and not super duper fast. So I'm gonna demonstrate that in Godot in that case to show you how this is working. So I have written some code here. So let me tell you what we're gonna do. So first things first, I'm gonna enable VSync from my graphics card because I noticed that the VSync option in Godot doesn't work for me. So I have to enable it from the NVIDIA Control Panel in that case. Second thing I would like to do is make sure that when I enable the vertical sync, I want to make sure that my monitor is running in 60 Hz. This is just for the example. Your monitor can run in whatever refresh rate. It's just I'm gonna demo this for you. So it is important to know what is the refresh rate of your monitor, and it's important to know that the VSync is on in your monitor in case you would like to follow along with my example. Then what we can do is go to project settings and make sure that the Force FPS is 0, so we are not limiting the FPS in any sense in that case. And also the VSync option. VSync option must be somewhere here. It's disabled. It doesn't matter for me. This never works. It will if you toggle this, you have to save and restart. I'm not gonna touch this for now because, as I said, it doesn't work for me. I have to do it through the NVIDIA Control Panel. So what we have now. Another thing is the screen. So if I go to the, where is the window here? Window, you see that I'm using width 300 and height 300. So my screen, my window for the game will be 300 by 300. Okay, so the question is that you have to ask yourself, how fast you would like your player, your object in the game to move. What is the speed, the velocity? So having said that my game is running at 300 by 300, in that case, we want, let's say from the left, from the very left to the very right, to take about 5 seconds. Okay, so that means 300 pixels, the actual distance, divided by the time, that's 5 seconds. So 300 divided by 5, it's 60. So 60 pixels per second. That's my speed. Imagine that you are driving a car. You are doing miles per hour or kilometers per hour. The speed metric here, like the units, is pixels per second. That's what we're talking about. That's the units. So we know that we would like to have, as I said, 60 pixels per second. And now to go from left, that's width 0, from to the right, that's width 300, because that's the distance. The object must move 60 pixels per second. So in 1 second, our screen updates 60 times. So for every frame, the iteration must be 60, which is the pixels per second, the speed, multiplied by 1 divided by 60, which is second per frame. And then we will have 1 pixel per frame. I have this here. If you would like to see the math. Okay, 60 pixels. This is the velocity, and this is the frame per second. So this is what we have to do in order to achieve that in a frame-based motion in that case. So for every time the screen updates, the object should move at least 1 pixel to the right. So what I'm doing here is I have the movement, the vector, and I'm saying, and I put that number, that's 1, this is 1 pixel. So pixel per frame, given we are running at 60 FPS and given the screen resolution is 300, okay? So if I do that, this is the code I have here. I'm gonna press play. So you see it's moving, the tree is moving. Here we see the output. And it finishes. I have put an if statement to stop when it reaches the 300 position. So what we see here is that, let's go up when it started. So we see that the game takes some time. There is an inconsistency here. So that is why I have put a check here. If the game is not running at least at 30 FPS, do not start moving my object. This is just for the demo purposes, to make sure that I actually start counting everything when the engine has started. So there is some inconsistency as soon as it hits more than 30 FPS, in that case 60 FPS, and you can see it had 0 FPS and went from 0 to 60. Then we start counting. We are in the virtual function process here. That's the game loop basically. Here, this is the function that loops, and it's getting called every time we have a new update. So 1 out of 60 frames. This is the delta time. Delta time is the time it took from previous frame to the next frame. Let's say we are in frame 6 here. So the time from frame 5 to frame 6 was this delta time here, 0.0166 whatever seconds. Okay, this is the delta time, is the time between the frames. Between the updates. So you see here that in each frame 1 out of 60, position 1, frame 2 out of 60, position 2, frame 3 out of 60, position 3. So for every frame you see that my object, this tree, is moving 1 pixel at a time, exactly what we would like to have. And after some time, we see here when we reach the position 300, it took nearly 5 seconds, 4.999667 seconds. So yeah, pretty much 5 seconds. and that was it. This is the frame-based motion, frame-dependent motion. Now, what is the problem with that? The problem with that is if I go here now and, for example, disable VSync, so it's not locking everything in 60 FPS, all of my calculations are for 60 FPS. So now that it's gonna change that, it's not gonna be stable. Let's see what's gonna happen. I'm pressing play. Much faster. Now the tree managed to go from left to right in less than 1 second, 0.994 seconds. So now you see that the frame was 286, for example. Yeah, it went from 0 to 286, and this might also change while the game is running. It might not be consistent. If we had longer distance, for example, it might change again even within the game. And I think I found a bug in Godot, because when I'm touching this thing with the mouse, it crashes. So I'm gonna start this again. Okay. Sorry for that. Okay, here we are. Perfect. So let me run it once more just to see what's going on here. So you see it changed 2 times now. It changed from 0 to 269, and then from 269 to 284, and now it took 1 second and something. So it's not consistent. That means the speed of your character is based on your frame rate, is based on your hardware, is based on VSync on and off, is based on your monitor refresh rate. It is a lot of components that affect the speed. Let's say one case to demo this is if I go here and say, okay, I want my game to run at 30 FPS. I can go to project settings, search for FPS under the debugging session here, and I say run this in 30 FPS. That takes quite some time. So it's, you see, double the time. In 60 FPS, it took us 5 seconds. In 30 FPS, it needs 10 seconds. It's like half of it is the double in that case. Yeah, and that's a problem. You would like to avoid this. You don't want to have that, okay? That's a real issue here. So to fix that, basically, you have to make your motion independent of the motion. Of the frame rate. There are a lot of ways to do that. You can do all sorts of hacks and stuff like that. One way, for example, is to go here in the code, and every time your speed changes, your frame rate changes, you have to recalculate everything from scratch, and then calculate also the distance, and then calculate also the resolution, because now we are also taking into account the resolution as well. If the resolution changes, things are changing here. So if you don't want to do all those hacks, one easy way to do this using the process delta function, is by going here and actually saying what your actual speed you would like to have. So if the speed you would like to have is 60, remember here, let me remind you, here 30 pixels divided by 5 equals pixels, 60 pixels per second. That is the speed, okay? So in that case, this is our speed here. So instead of putting the pixel per frame, I'm putting the pixel per second value. This is the pixel per second value. This is the pixel per frame value. And in that case, I can go here and multiply the movement by delta. Multiply the movement by delta. And just by doing that, if I press play, now you will see that in 30 FPS, in 30 frames, it's 5 seconds. It's fixed. This is fixed. So this is one way to fix your problem. This is one way to make this happen. Let me just, for the sake of demoing, put this to 0 again, and VSync is off. So I'm gonna play again, so you can see that it doesn't matter. So again, with nearly 300 FPS and inconsistent FPS, it took 5 seconds to go from one position to another. So it was pretty much consistent. Now, if you want to be really accurate, and when you are using motion for your player, that's physics and stuff like that, what is recommended in Godot, and now this is the Godot way of doing this, because I just showed you a general principle that you can follow in any game, pretty much in any game engine. You can go to your code, and instead of using, where it is, instead of using the delta, the process virtual function, you can use the physics process. Sorry. And this is equally handling the problem as well without an issue here. That means if you do that, now it's of course gonna work as well. Okay, and even if let's try to remove that and enable the previous example. So in our very first example, we had something like that. That was my first example where the code ran within 1 second. And if I run this now, you will realize it fixes it and it makes it run within 5 seconds as well. So instead of putting here your velocity or whatever, you can also do it like that. You can put, you can have your code that you wrote in the very first time, that you calculated everything based on the frames, and then use the physics process. This is because the physics process actually applies some kind of vertical thing, or I don't know, that logs everything within 60 seconds, and no matter of the FPS is bananas here, 2429. You see here that every 60 frames it updates. You see, because of my counter, I can see it. See the counter, every 60 frames it updates. So the actual FPS here is 60. I don't know why it says that we have 2000 plus whatever FPS here, but this is what actually is happening. So all in all, just to finish this, what I would actually recommend you to do is to not use this, to use your actual speed that you would like to have. So go here and say, I would like to move pixels per second, because that's the speed here. And then your speed, no matter if you are using the physics process or the process itself, so no matter of which function you are using, it will always be correct in that case. And always use the delta to make it as it should be. So that's all. Thanks.